All right. So so the, to so the discussion Ben and I are having is about whether we should have a new API called Cozy Driver or Cozy Provisioner. And the idea behind that API is, um, it represents the name alone of a particular Cozy driver for now. So what Ben is saying makes sense to me. That is, he's saying it is not necessarily required. I had some slides prepared for this. What I'm looking for. He's saying it's not necessarily required.
You
And
mean
what?
a new CRD? What do you mean a new
Yeah,
API
yeah, yeah. New
CRD?
CRD, yes.
Okay.
And that might work. But if you had this object, you can make sure that there's only one provisioner registered by a particular name.
Yeah, so the way that we handled this on the CSI side was just in the spec say that when you create a name, it must be a fully qualified name and include kind of the domain of your company and everything. And therefore, it just naturally dedupes. And so you have something like EFS dot, I forget, it was like EFS.aws.io or something like that. So that in itself is how we handle the deduplication. It hasn't really been a concern. The CRD that we create, the CSI object, is actually optional on the CSI side. It was created more for allowing a driver to be able to customize how Kubernetes interacts with it rather than this collision case. Since it's optional, it doesn't necessarily handle the collision case, even though, I mean, it could if two drivers ended up creating the same object. But more so, it was just, hey, I have a driver that wants to customize how Kubernetes interacts with it. When it is installed, it creates this object and says, I want to tweak such and such behavior from default to something new.
Who reads that object?
Who reads it? Kubernetes, various components in Kubernetes. So for example, it has one of the fields is like skipping attach. And so the attach detach controller will read that object and say, oh, for this given CSI driver, should I skip attach or not?
Right. No, yeah, I know what you mean. Yeah. I know what you mean. Yeah, I've used that parameter. Yeah, that makes sense. Do we see something like that ever being required here? I'm asking this question as an open-ended question. I'm also thinking it through. So my original idea behind this was more like register a driver, know that it's there. And I was thinking we'd do it automatically, not via the user, but when the plugin registers, we would just go ahead and create this object.
Yeah, you could do that. You could have a controller that like watches for new plugins. When it sees a new one, it registers it, creates this CRD object, and it probes the capabilities of the driver and then populates the appropriate fields in the CRD object.
Yeah.
And that way it makes it more accessible to Kubernetes controllers.
Right. That was the idea.
Yeah. I think it's a good idea. I would say put a pin on it and say, here's a hypothetical of what it would look like. And then when we have our first concrete use case that you need it, pull it out and implement it.
Fair enough. That would work. Yeah, no, that would work. Yeah, we'll just, I don't think we'll forget it. So yeah, should be fine. If we were to do this, we'll also have to think about unregistration or deregistration. But if we were to automatically register it, how would we automatically deregister it becomes a question. I don't know if you're going down a rabbit hole that we need not right now, but it might be a quick discussion to just get it out of the way.
Yeah, the life cycle of registration and unregistration at the cluster level gets tricky. At the kind of node level, it's trivial because you could have like a socket that the driver has to call into. At the cluster level, it definitely gets more tricky. So you'll have to think about that a little bit.
Right, exactly. How do we detect it's gone? Yeah, yeah. Wait, what happened? I don't have a solution either. Let's see, where did it go? All right, here it is. Okay, goes here. Okay, yeah, it gets tricky. So this is good to know. I think in that case, like you said, we'll put a pin on it. I think right now, if two different provisioners for different cloud providers end up registering with the same name, both would get this request. And they both might end up provisioning a bucket. But you know, that's kind of a unique scenario. It's one of those scenarios where we call it user error, because the bucket creation can only succeed for one of them. Well, no, never mind. So okay, so this is how the workflow would look if there are two different drivers for say two different object storage vendors registered by the same name. Let's say you use some name like test cluster or something like that, and you end up having two different instances of test cluster, um, one installed by a different person in the same team as you, and then you just end up with two. So when a bucket request is made, pointing to a bucket class that wants a bucket of type, you know, from the provisioner test cluster provisioner, um, our central controller would create a bucket object, um, and the two different sidecars would respond to that bucket object.
They'd race with each other.
Yeah, they would.
And we have this exact same problem in with CSI drivers, and we just say it's
your
user
problem.
error if it happens. Yeah, it's not something that we worry about.
Yeah, I think that's fair. I don't think it's a problem actually. I mean, I think taking on this complexity is worse than yeah, I don't know how to unregister a driver. That's my main problem with this. So yeah, I think it's fair to call it a user error at that point.
Wait, what do you mean unregister a driver?
Oh, okay. So earlier I was just saying one way to prevent that race from happening is if you were to have a unique driver registered per sidecar or create a Kubernetes object by the provisioner name for each provisioner that comes up, and it will be automatically created by Cozy based on the identity of the actual driver. The problem is, how do we unregister it? Like if we automatically register it, how do we get rid of it when the driver goes down?
Oh, right, and we can just say non-problem, right?
Oh, like we don't get rid of it?
I mean, again, in CSI, like you just delete the object and delete your storage class, and now all your PVCs are broken. But like, uninstalling a CSI driver is something that kind of doesn't happen frequently, if at all.
I see. But what about upgrades though?
So on upgrades, like most of the objects stay the same. You just basically stick in new bits. So you tear down the deployment and update the image name, or you update the image name of the deployment. It kills all the pods, and new pods pop up. But any operations that were in flight at the time just get aborted and retried.
Oh, I meant more like during an upgrade, say the provisioner name changes or something.
No, you can never change a provisioner name like that.
Fair enough.
That would cause huge problems in CSI.
Right.
Presumably in Cozy too. So yeah, once vendors need to be aware that like this string that you pick is set for all time. And if you ever change it, you've basically made a new driver and orphaned your old driver.
Yeah, I would stick with just really strict regulations and requirements on the naming, and make it very clear that the name is important and should be unique.
That's fair. Okay. All right. Let's leave it at that then. Yeah. we don't have to enforce it in code. I think it's this is good enough. All right, so Saad, since we have you here, I don't know if anyone else has joined. Let me see. We have Sajan, we have Aaron. Okay, so I want to continue the discussion that we left off last week, Saad. And we did continue it on Monday as well. I don't know if you had a chance to look at the recording. Did you?
I did not know. Was
Okay.
Andrew and Tim part of that discussion?
Yeah, that one.
Okay.
Yeah. So last we left off, we were questioning if mutation at all should be supported, and it seemed like um, mutation may not actually be a regular use case. If at all it were to it was needed, it was a rare event. Um, and but still we wanted to see if let's say it does come up as a requirement in the future. We wanted to know that there would be an approach to to take care of it if needed. um, so that's where we left off last week. We had a discussion on Monday continuing that conversation, and the people that were there on the call, I mean, I don't want to we didn't explicitly do a vote or anything, but we pretty much all agreed that this is indeed a rare event. But Ben did bring up that we should still have a solution in case this becomes this becomes an absolutely required feature. And
well, that had been Tim's request.
Yeah.
I was echoing his request.
Yeah. No, it was a valid thing, Ben. You reminded us of it, I would say. So following that, one thing we said was we could have the concept of a bucket mutation policy. Again, we'll only do it when this is a requirement, but we can have the concept of a bucket mutation policy, and that would be set on the bucket itself. And only the buckets that have the bucket mutation policy can be edited by the admin, and we would respond to that edit event through the controller and call a driver function that will go mutate the bucket. That was our solution for the bucket mutation.
And just to make sure I understand that, so effectively the cluster admin controls whether mutation is allowed or not. By default, it's not allowed. They can choose to allow it by setting a bit on the bucket object. And if they choose,
and it comes from the bucket class, so like you can set a bucket class to allow everything, the default is on or the default is off.
I see. And then if they choose to allow it, anybody who has a bucket request pointing to that bucket object could do a mutation?
No. So if they choose to allow it, so if we were to go through like the actual workflow, let's say it's not allowed by default, and then the admin copies the bucket for another namespace, and in that copy the admin sets the bucket mutation policy to allow.
So the bucket mutation policy is set on the bucket request or the bucket?
The bucket itself.
On the bucket itself. Okay. Okay.
And then the cluster admin would be able to go mutate that bucket later on, let's say when the mutation is required, and Cozy would respond to that and allow call the driver.
And sorry, I forget, did we do a one-to-one or n-to-one mapping from bucket request to bucket?
So bucket request to bucket is one-to-one.
Okay, so then effectively it's only one namespace that gets access to mutation. Okay.
You can have multiple namespaces with the mutation policy set to allow.
But they would have separate bucket objects.
Right. Separate bucket objects, bucket requests.
Got it.
Yeah. If at all this is required, we can address it this way. I wanted go ahead.
I was going to say, so I guess the original concern that Tim had, and I'm going to try to paraphrase, was along the lines of as a application developer, if I provision a greenfield bucket, being able to not switch, for example, the access modes of that bucket in the future would be limiting. And so I guess this would allow that through setting a bucket class with mutation allowed, and then whoever the application developer is can use that bucket class to provision a new bucket, and they will have permission to mutate it as they wish in the future.
Assuming they have access to the bucket, yes.
And this allows us to maintain the same API for both greenfield and brownfield.
Yes.
I think that was one thing that Tim started going towards, was like, oh, it seems like we need separate APIs for greenfield and brownfield.
Well, it doesn't change that part. So we don't have separate APIs as such. We have separate workflows. What I mean by that is when we create a greenfield bucket using a bucket request, we don't specify the bucket name. But when we create a brownfield bucket using a bucket request, you specify the name of the bucket that the admin gave you.
Yeah, I think that makes sense to me. I don't personally understand the reason for having separate API. I think if at all possible, we should have the same API.
Yeah, we don't have, so I don't know what a separate API means here. It's a different parameter. It's like choosing a flag.
I think the proposal that he had was along the lines of there's non-name only namespaced objects for buckets, and they live inside of a namespace. That namespace owns them. If somebody else wants access to it, they can get a pointer. But if they have a pointer, they're not allowed to mutate. You have to have the actual object in order to mutate, something like that.
Wasn't one of the proposals to do something along the lines of like cluster roles and roles and cluster role bindings and role bindings were like the,
I think so, that's what you're talking about, right?
What was the gateway one that we are?
So this is how Tim explained it on the call with just me, Tim, and a few others, like Jeff and others. I think others are invited too, but I don't know if you can make it. He said in case of gateway at Google, and correct me if I'm wrong, there's a central team that manages a particular kind of gateway. And then per team, or say one of the infrastructure teams, gets to manage their own gateway in their own way, where the central gateway team has no clue about, as long as some set of policies are followed. And so they have the concept of both cluster gateway and a namespace gateway. And just like cluster roles and roles, where you have cluster role bindings binding to cluster roles and role bindings binding to roles, we have a similar kind of dichotomy going on there as well, where you'll have bucket requests and buckets that are purely namespace alone, and there are bucket requests and buckets that are purely clustered alone. But I don't know how they interact or anything. But the idea is they're separate, I think, to allow two different kinds of users to work with them. I'm giving you the best understanding of.
But do we still need to have the Baowei to actually explain to us how that works, and then kind of try to do something similar here, or are we? Because it seems like we're still not knowing exactly what that.
I mean, in
works,
terms
right?
of direction, I think.
Do they actually even have like a document or something? Or is that's not public? That's not. It's inside Google or something, or is it?
Oh no!
Already out.
The gateway design. Yeah, the gateway design is public, so there's a
yeah.
proposal
Is
for
there
it.
A link? Maybe we can even take a look if if
Yeah.
they can't present, we can at least take a look of that. Because I heard them talking about this. Not clear to me exactly what we.
Yeah, I
trying to do there.
Again, this whole thing is.
I was searching the other day. I didn't find anything that says gateway, so I'm not sure which one they're talking about.
Yeah. So the reason Tim proposed this was to allow self-service, but it adds other complexity at the cost of. In order to provide self-service. So let me see. So it is called gateway I've seen it. Okay, let's see. Issues. Ingress names, paste items. Okay, let me see. It's definitely not Q by ADM. It must have something to do with SIG network, dual stack, interface name, gateway, mixed protocol. Not this, because in that case they're talking about like a network gateway to talk to a different network, like the public cloud. I think it's probably this service LB class field. No, not SIG cloud provider. It should be in SIG network. Oh, maybe this is what it is.
This is the link that they gave you, or you're just guessing this might
No,
be the one?
they said there's a. I'm guessing because they said there's a proposal.
Yeah, I was searching. It's not clear to me exactly, but of course I don't really know network that much, so I'm not. It not clearly says a gateway in the proposal. At least I couldn't find one. Yeah, I saw that one you were looking at too. I'm not 100% sure that's the one. We can probably even just ask them in that email thread. At least if they can't come, we can at least take a look of the proposal and see what that means. Because otherwise, I don't get what they're talking about.
Yeah. To be honest, yeah, I was hoping they would join too.
Mm-hmm.
Yeah, I don't know. Let's do that. We'll ask them. But even if they don't respond, we do have a path forward, I think. All right. So I think this is good. So I want to take care of some kind of logistical things while I have everyone here. So Saad, you asked a bunch of questions on the spec pull request. I think this is a good time to address them. 6 container object storage interface spec. It's a closed PR, but I think we should still address them, even though it's merged. I think this is the one. Not this one. What's this? Okay. Okay, we took care of that. We moved this to an identity service. How's it different from screen? We added comment. Expand the name for bucket name. Okay. Yeah, this is one. You asked if deletion does require opaque parameters. And our answer was, at first, I didn't think it needed the opaque parameters themselves. And later on, when I thought about it, I can see it needing the same parameters that would be needed by, for like create bucket. Say there's a vendor specific parameter that's needed for whatever reason. It's hard to predict that we'll never need something like that, especially given that protocol is restrictive for a good reason, but it's restrictive. If we did want to pass some parameters, we wouldn't be able to do it if we don't have the opaque parameters for deletion.
Yeah, so I think I would special case deletion, right? We want to be as kind of protective of deletion as possible so that you never end up in a state where Kubernetes can't do a cleanup. And for that reason, I would say let's start with the bare minimum that we need and then add to it as needed. In general, the idea is that the unique identifier for the bucket ID should be sufficient to identify it. Like you should not need anything beyond that bucket ID to be able to say.
Not for identification though.
Right. So what else do we need beyond identification on a deletion? For creation, there's secret? Exactly. Secret is the only other thing that we can think of. And on CSI, we even said no secret, specifically because we don't want to end up in a case where, cluster kind of lost some state and now it can't do any cleanup.
So we can set up like Lambda triggers for buckets, something like on every object create, call this Lambda function. Stuff like that is something you'd want to delete.
Sorry, could you expand on that?
So with MinIO and with S3, what you can do is you can set up triggers on events on the bucket, on a particular bucket. So say, for instance, you set up a trigger for a bucket creation, or sorry, the object creation, or say object deletion. Then when an object is created in the bucket, this object is pushed into the bucket or put into the bucket, a Lambda event is called. So, we call an endpoint saying this happened. And that endpoint can respond to it in any which way it wants. It's like a webhook. So stuff like that might need to be cleaned up.
And so you want to be able to customize what happens when deletion is called.
Yeah, or just a set of parameters that say that there is this feature has been enabled. So go check for it.
And how would the CO know that this feature is enabled, and how would it be set?
In the parameters, you'd have a vendor specific value to say that.
Right, but how does Kubernetes set it?
Through the parameters, it's opaque to Kubernetes.
But Kubernetes needs to get it from somewhere. Is it stored in the storage class? Is it stored somewhere else?
Right. So this would come from, so whatever parameters we sent, it's stored in the bucket object. So whatever parameters we sent for the create bucket, we would send the same thing over here.
So what that sounds like to me is you're using Kubernetes as a place to store state and then passing it back in at a later point. So we should avoid that and instead say, okay, this is something that you can configure on the bucket, whatever the deletion policy should be. You can do that at creation time if you like. And then the bucket needs to remember that. So when the deletion is called, it will go and execute it. So for example, if you have, a policy around what happens to Lambda functions, you can set that up front and say, delete all Lambda functions when deletion happens.
Okay. In that case, we're asking the driver to hold the state somehow, right?
Yes.
Okay. Both would work. This would make the driver's implementation simpler. So
yeah, we had the same exact kind of back and forth on CSI, Ben. I don't know if you remember this, on how much state we want Kubernetes to carry versus the driver. And I think in general, what we pushed towards was don't use Kubernetes to carry arbitrary state. It doesn't do a good job and may lose its mind, and you don't want to be kind of make Kubernetes responsible for holding that state. So just make the driver responsible and they can make the decision. What's that?
That makes sense. Yeah, if it was transient state, that would be a problem. But this is state that's set during the creation, and it's not considered mutable. And we can.
Yeah, and that's worse, right? Like you don't want Kubernetes to lose its mind and then forget what the policy for deletion of these Lambda functions, for example, is.
Wait, how would it do that?
We've had cases where API object gets deleted for some reason, right? And you recreate a object to represent that bucket.
Well, we have a finalize on the bucket, so it won't get deleted unless the delete is called and we remove the finalizer. And if the bucket object gets deleted, you can't. You're in a bigger problem than.
I guess the bigger problem is basically it's a violation of abstraction layers here, right? Like this policy, Kubernetes doesn't care about it. So to use Kubernetes to store and propagate this policy doesn't make sense. It's more of a like, where does it actually belong?
Yeah, it's not coming back from the driver. This is coming from the user when it was set the first time. It's not really state as much as it's spec.
Right. And so we're saying that when a bucket is provisioned, there is some policy about deletion that we want set. So go ahead and set it right at creation time.
Well, let me put it differently. So it's not okay. So it's not okay. Maybe the Lambda example wasn't the best one. So parameters exist specifically to allow vendors to configure, vendor specific values. And I had an example here. What did I call it? Yeah. So like you want to set the encryption key store in case you're on Ceph, and you say, we're using Vault versus some other key store. And if you're on AWS, this doesn't apply because AWS has its own.
Yep. So that makes sense. Like you set that up front on your creation side.
Mm-hmm.
Why must that be passed in at deletion time? Right? Once the bucket is provisioned, the vendor should know everything about it.
Yeah, I think that's fair.
If a user's generated on the fly as part of Greenfield, how is the provisioner supposed to remember that? I mean, it seems like we're putting. I understand philosophically what you're saying, Saad, and I agree with it. But it seems what the difference that Sid's bringing up is that this is static information. It's not transient. It's not current state of the world. It's just some pieces of information that the delete interface needs so that so a provisioner can delete a bucket, like a generated username, which isn't known in advance. Where do we store that, or how is a provisioner supposed to do it?
If you know that information at creation time, right, you could have Kubernetes pass it in.
It's generated by the driver, say.
If it's generated by the driver, then the driver knows it. It can persist it at some point, right?
But yes, the driver can figure out, every driver can figure out how to persist it, but why can't an opaque, unchanged type be kept in the bucket instance?
Effectively, what that looks like is like a cookie, right? You're passing a cookie back to the user and saying, please pass this information back in at the future. And that's just a model that we try and avoid, right? It's just you're using Kubernetes and you're using the end user to hold state. And we're saying, don't do that. If you have something that you need to persist it on the driver side. Don't try to use Kubernetes or the user as a way to pass information back to yourself in the future.
And that breaks the declarative API philosophy in some way.
It's not necessarily the declarative API philosophy. I think it's just a abstraction layer thing. Why are you pushing this out to the user and back in? Like just persist it internally, and then when you have the deletion request or any other lifecycle event that happens, you have all the complete information you need.
So I generally agree with what Saad is saying, but I think I'm missing some context for what the problem is that we're trying to solve.
Okay, so on bucket creation in the gRPC spec for provisioner create bucket request, we pass in a protocol structure, and we pass in an additional opaque set of parameters.
Yeah.
Now the question is, are these parameters required during deletion as well?
Oh. What?
So
why would they? I mean, why would they be? Because the whole point of the creation parameters is there for modifying what happens at creation.
Mm-hmm.
They're not for just extra
Actually,
data you're always going to get, right?
Yeah. No, I think you solved. Yeah, you cleared me out on that one question. Yeah, you're right. We shouldn't need them then. Yeah, I see what you mean by abstraction problems. So it's not a problem with. So we were more arguing from the idea of this, it's symmetrical, and what you're doing is not really technically breaking any conventions, and we just assumed if it's needed, it should be there. but you're right. If parameters are there specifically for creation alone, then they shouldn't be needed for deletion. That's what you're saying, right?
Yeah, well, and I'd like, if there's a counterexample of like, this is something we need for deletion, we should go through like, how should that be handled? Because in general, it's assumed that when the create call comes in, if you generate any information on this, on the, you know, the cozy side, you store that with the bucket you create, so that next time you get a request to do something with that bucket, you can just pull it back out of wherever you stored it.
Yeah, so we just considered, so yeah, one of the ways we were looking at parameters is not just as some set of parameters for the bucket creation, but more like some set of parameters that help you communicate with the driver. But that doesn't make sense, I think, if you were to look at it that way, because
at least on the CSI side, they were very explicitly just for creation. And if we
if you
mirror
just
that
have
here,
like a first class field like secrets, I think that's fine. Then that's actually consistent with what we have for CSI.
Don't we have like in CSI like a parameterized like map string where, you know, if you give a certain key with pointing to a config map?
There's two specific places in CSI where that happens. One is create volume is able to return a volume context, which is an opaque map that will get stored by the CO and then supplied back to a couple different calls. And then controller publish volume also gets to generate another opaque string map called the publish context, or
right.
and then that similarly gets stored on the CO and then passed down. But it's like those are two very specific calls that can return very specific maps with limited size and all that stuff. And we know in Kubernetes exactly where we're going to store them and then where we're going to supply them back. They're not general use there. It's because those specific calls have to communicate something from the controller to the node, and that's the mechanism for that communication.
Yeah. So if you look at in CSI, unpublished volume request, other than volume ID, we pass a set of secrets.
Right.
Yeah,
so you can have
secrets
that,
are
right?
special.
That's fine. Yeah, you can have secrets.
That was the, yeah, but the secrets, do they not apply during create as well?
Secrets is also in create.
You get secrets everywhere.
But you don't have parameters in it like unpublish or delete, right?
Right. So you're saying for specific fields we can actually have them, but I think Sadhus was saying that earlier, just about this in this conversation. But opaque set of parameters may not be needed. That's what we're saying.
Well, the create parameters I think are intended just for create. And delete in particular should be able to function without any information from the CO, because delete can be called under emergency circumstances where you don't have any information, right? You're just trying to clean up.
I see.
And in other situations, yeah, like if you definitely need something that can only have come from the Cozy plugin, then you either put the burden on the Cozy plugin to communicate itself internally, or if you have the, you know, like CSI with the node controller split, if information has to get from the controller to the node, then the CO becomes responsible for communicating that specific information.
Yeah. And it can do that using its custom objects, CRDs or whatever.
Well, so the place the volume context gets stored is in the PV itself.
Well, I mein, like if the driver wanted to, you know, hold some state when it, you know, in case of CSI, it could always put it in a custom resource.
I mean, CSI plugins aren't supposed to know about Kubernetes, right? That they're.
I mean, like, yeah, fair enough.
I mean, you can write a CSI plugin that only works with Kubernetes, but then it's not a CSI plugin, because if you try to run it without Kubernetes, it's not going to work.
Yeah.
So that's the bad model to assume something like Kubernetes underneath your Cozy plugin or your CSI plugin.
I mean, yeah, no, that makes sense. No, that makes sense. Okay, so anyways, that's we're getting sidetracked there. I think I understand where you're coming from. So we're saying if there is something like secrets, which we know is utilized by the driver to communicate with the backend. Stuff like that, they should be explicit rather than be combined into the parameters field.
But it's also worth understanding that secrets are very funny in CSI in terms of how they get generated and where they come from and how they're used. I would say the majority of CSI plugins don't use secrets at all. And those that do have special rules. It's extra parameters you have to put in your storage class so that it knows where to get the secrets from. And then the external provisioner sidecar looks at the storage class and stamps a bunch of secret names on the PVs that it outputs so that other things will know where to get the secret data necessary to make the various calls. And there's these pathological corner cases where you can like have different secrets for different calls because of the way it's implemented in the sidecar. So it gets, the secret handling gets very complicated and most people just don't use it, but it's there.
Makes sense. Yeah, makes sense. All right, so I think I understand. I think if we were to be clear about our definition of parameters, that would clear a lot of things. I think we should add a comment. We should update the spec and add a comment in parameters, and we should say that parameters are meant for plugin or driver specific values for creation of the bucket itself, and that'll clear up this this thing with having parameters and delete.
Sounds good.
Yeah, yeah. So Saad, we'll make a PR with that one change.
Yep, sounds good to me.
Yeah, and okay. So we have similarly we have parameters for grant bucket access, and I think we have parameters in revoke bucket access also. Would this apply? Would parameters apply here, or would this be similar to create and delete bucket?
I would say the parameters should only be available in create, because that's the
Plus
only time
one.
that's the only time the bucket class is guaranteed to exist. Someone could delete the bucket class immediately after creating a bucket, and then everything else is expected to work.
I mean, even during create, it's not guaranteed to exist.
Yeah, it is. I mean, you have to have a bucket class when you create a bucket.
Well, we copy the fields from the bucket class into the bucket object. So we don't need a bucket class at that point.
But I think what Ben's saying is at the point of processing a BR, one of the fields is bucket class, which is required.
Right.
That bucket class has to exist. If it doesn't exist, Cozy will throw an error. And
yeah, but that doesn't play into this gRPC spec though. Yeah, I see what you mean, Ben.
Right, and after the create succeeds, you can delete the bucket class and everything else is supposed to continue to function even though the bucket class is gone.
Yeah, makes sense. Okay, so yeah, I'll also make this change then. We'll remove parameters from revoke as well, and update the comment on the parameters field to specify that they're vendor specific fields for creating a bucket and creating credentials for that bucket or granting access to that bucket. I believe you left another comment, right, Saad?
Yeah, I think the other comment was around the naming. So there's a bucket name, I believe, or bucket ID that's defined, but not both. So you pass in, so I think my expectation was kind of what we have on the CSI side, which is volume name passed in on the create call. And then on the create response, you get a volume ID, and then all future requests use the volume ID. It sounds like instead of that, for Cozy, the proposal is to just have a single bucket name, and that's used everywhere. There's no concept of a bucket ID.
Right. Our reasoning for there was an explicit decision. We said, or the reason we made it that way is because I think it's and again, this is open to discussion, but I think it's safe to say that bucket names are globally unique. And I say globally unique for that provider, for a particular provider. So bucket name is, just by its nature is actually a unique ID.
So I guess what's the drawback of letting the driver declare what the actual bucket's unique identifier is?
Well, in S3 or in the other providers that I know of, there is no concept of a bucket ID.
Right.
Right. So
they could just return the name back as the ID for themselves.
Exactly.
But if somebody wanted to have it, I remember this discussion from earlier, and I remember having it. I don't remember what the content of it was, and
we never reached a conclusion. We just left it at I think we all kind of agreed that it can be globally unique, but we never explicitly said that means we should just have bucket name.
You had convinced me that there wasn't any real problem with just forcing the ID to be the same as the name, so you don't have to store it. But like, just because we didn't find the problem doesn't mean it doesn't exist.
No, it's not that we didn't find the problem. I'm saying the problem cannot occur because the name itself is the ID. Like if you
no. I mean, there could be a reason why when you use the name as the ID, you get into trouble. And I think what Saad is asking is the flip question, which is, given that you can just make the ID identical to the name in some drivers, if they want to, if other drivers want to make it different, like what's the downside of that other than you have to store it on the CO side? So he's asking the flip question. Like if we do follow the CSI model and say the driver generates the ID and the CO stores it, and then further calls refer to it by the driver generated ID, what is the downside there?
Because one of the things we in our architecture, one of the things we said was the provisioner or the provisioner sidecar would only be able to read buckets but not write to it, because we just didn't have. Wait, no, never mind. I don't think we said that. Let me. Yeah, so the idea was, at least the way we've looked at the gRPC API so far, we don't use the responses to fill values back into the bucket. But
you kind of have to fill something in when,
I mean, we say bucket available to true, but that's not a value that comes back from the gRPC spec or response. Not that it's not possible to do. It was more like if you look at any of the IO calls, like create an object or list objects or whatever, the bucket name is the unique ID.
They said, is the name unique across all zones and regions?
So the bucket naming is it's a DNS name. So the region and zone gets factored into the name. So AWS S3 bucket, it looks like a bucket name .us east 1 .amazon AWS S3 .amazon AWS.com.
So how can the CO be expected to have generated that name? It's not going.
Is this user provided, right? The name is provided by user.
Well,
so
the name is
if
provided
user
by
does
the
not provide a
sidecar.
name that has all the information, then what will happen?
Yeah, Ben, you're right. Yeah. So we can't expect the sidecar to generate for every driver.
So what you're describing is that's the ID.
Hold on. When you create it, When you create it, you provide a name, right? So it's a user provide this name in the bucket request, right?
Yeah, it gets.
So, and then does that include the region and all of those name already? You expect that you have to make sure that is valid or something, or?
Yeah. So those things are passed in through the protocol structure. So like in the bucket class would be set, but taking those values and creating a bucket ID from that is not something Cozy knows how to do.
The driver knows how to do it.
Yeah, driver knows how to do it.
So that argues for returning back an ID.
So you're saying, okay, actually, so if I say, I just want to say, I want bucket just cause my bucket, that's actually okay. And then the driver actually will go see whether it's from the, this region, or putting all those together and generating a name. And then
that's called the ID.
That.
Yeah. So it would send just the bucket name and say, create this bucket name in region US East 1 or whatever. And then the unique ID will be returned to us by the driver. So Amazon's driver will return it to us. So we'll need like Saad and Ben are saying, I think that field should be populated back into the bucket, and that should be used for future requests.
Yeah, that's exactly how CSI works, and it's been a great model.
Mm-hmm. Yeah, I just didn't see a need for it, and I kind of just thought this would work. But yes, the question of how would we construct that unique ID is not something. I mean, we should not be doing it. Cozy should not do it, because it changes per driver, and if you get into that business, then it'll become a problem.
Now, I just want to throw one more wrinkle into this, which is on the CSI side, what actually happens is like you create a PVC name, and then the sidecar will then take the UUID of your PVC and generate a PV name from the UUID, and then that's what gets passed down to the CSI driver. The CSI driver never sees the PVC name.
I know, we're doing the same thing.
Okay, so
the bucket name is bucket request. So bucket name is br-bucket request.uuid.
Okay, so for greenfield buckets, they're going to have these weird UUID names that are globally.
They also, for Cozy, you guys also did like a user prefix, right?
Yeah, we have a bucket prefix.
So it's like partially auto-generated, partially user-generated.
But it's going to be globally unique because it's got a UUID appended to it.
Right.
Yeah.
Wonderful.
Yeah, there are some problems with that I don't think we've sufficiently addressed. I don't know if we have actually, maybe I don't remember it, but one problem is the bucket prefix has to be valid for that driver. Because if you put in a bunch of hashes and characters that the driver cannot accept, that's not okay. And the second thing is the length of the bucket prefix should not exceed 8 bytes, or what's the length of UID? 16 bytes, right? So 16 byte or the maximum length of a bucket name minus 16 bytes. If it exceeds that value, then we'll have a bucket prefix that's too long, and we won't be able to create a bucket.
Yeah.
So I don't think we've addressed this very well yet, but maybe we can talk about. We're out of time. What?
We got 4 minutes. 3 minutes.
2 minutes.
Yeah,
maybe we address it on Monday, but I think this is good. I think we had a good discussion. I think we'll move forward.
We just need to define what should happen if the user passes in a funky prefix, because drivers could mangle it or drivers could reject it. I don't know. Drivers might have driver-specific length limitations that if it's too long, they might want to reject it. But other ones could say, sure, it's fine. We have to write those things down.
Yeah, because at one point we said Cozy was going to generate the bucket name, not the driver.
It's still the case, Jeff.
That's still the case. So you could argue Cozy shouldn't know any rules about a physical bucket name, and the provision or the driver just fails, creating an illegal bucket name, and we log the error.
Well, I mean, we need to be strict about what is acceptable at the spec level, and then if drivers have tighter restrictions than what the spec says, then they have to deal with it on their end. Either by mangling or truncating or whatever they consider to be a good way of dealing with it. But yeah, the spec needs to have, this is what's allowed. And then if drivers have looser limits, they can just accept it. And if they have tighter limits, they have to do more work. Because we can't know what the limits of every driver are going to be before we write the spec.
Yeah.
So unless we get that information from a get info call or something up front. But right, I mean, it's better to me if Cozy knows less about the rules of a back-end bucket name, and there's more flexibility for changes. Rules could change for different back-end bucket.
So yeah. All right. So Jeff, sorry to cut you off, but we're out of time. we'll bring up this discussion on Monday. But in the meantime, I'll make the updates to the spec and make a new pull request. Saad, please review when you get a chance.
Sounds good. Thank you.
And yeah, of course.